How do we find the axis of symmetry in the vertex if we have a quadratic equation in factored form? So this is a little different than when we have a quadratic equation in standard form, because our trick there was to use our formula x equals negative b over 2a. If it's in factored form, we don't have a way to find b directly from the equation. So we could FOIL this, put it in standard form, and use our formula there. But there's another way to use the symmetry of the graph to find the axis of symmetry from the x-intercepts. So remember, factored form makes it easy to find the x-intercepts. X-intercepts, we just take this 3, it becomes a minus 3, the minus 5 becomes a plus 5. So this is where it's going to intersect the x-axis, these 2 points, and then we just take the average, the midpoint, because this axis of symmetry, it's going to be halfway between 2 points at the same height. Negative 3 and 5 are at the same height, so the axis of symmetry will pass through the midpoint between them. So our trick is to take the average. So it's the average of negative 3 and 5. And the way averages work, you add the two numbers up and divide by 2. So negative 3 plus 5, that's 2, and then 2 in the denominator. 2 divided by 2 is 1. So our axis of symmetry is x equals 1. So you can always, if you have both x-intercepts, find the midpoint or the average, and that'll give you the axis of symmetry. And then to find the vertex, just like we do when we're looking for the vertex in standard form, we plug in the x-coordinate to find the y-coordinate. So we know that x equals 2 is the x-coordinate of the vertex because the vertex is on the axis of symmetry. And sorry, that's not an x equals 2, that should be x equals 1. Sorry about that. X equals 1. And then we go back to our original equation, y equals negative 2, x plus 3, x minus 5. And we substitute 1 for x and solve for y. So y equals negative 2, 1 plus 3 times 1 minus 5. And we simplify using order of operations. So negative 2, 1 plus 3 is 4, 1 minus 5 is negative 4. Negative 8 times negative 4 is, the negatives are going to cancel. We're going to end up with positive 32. Okay, so the x-coordinate was 1. And now we've just shown that the y-coordinate is 32, so that the vertex is at 1, 32.